So where we left off in the previous video, let's pick up from there. We graphed a function that had a slant asymptote, and we got the slant asymptote by doing long division. Now let's go quickly look at this on our TI. So let's clear that and put the function in. We had x squared plus 2x divided by x minus 1. Again, remember, put parentheses around the numerator and denominator. We'll do a zoom 6 for a standard screen, and notice it looks kind of like what we have, but you can't distinctly see where the slant and the vertical asymptotes are, but by doing the algebra we figured out exactly where they occur. Now, probably since the hardest thing about this one was figuring out the slant asymptote, everything else was review from the previous videos, let's just go practice a couple where we only find just the slant asymptotes. So we'll just practice finding slant asymptotes. Again, for the first one, upstairs the degree is 2, downstairs the degree is 1. So we know this is going to have a slant asymptote because it's 1 higher than the bottom. And we're going to get the slant asymptote by doing long division. So we're going to put x on the side and x squared minus 4x minus 21. And we're trying to get from x to x squared. So it looks like I need an x to get there. Once I have that x, I just multiply them. X times x is x squared. And then I subtract, immediately switch signs. I only have one term there. So they go away, and now I bring down the next term just like you would do in long division in grade school. So I bring down the next term, and now I'm at x squared, and I want to get to negative 4x. So to get there, I need to multiply that. I'm at x, and I'm trying to get to negative 4x. So to get there, I need a negative 4 up there. And then I multiply that negative 4 times the x, and I get negative 4x. And immediately switch the signs of all the terms. And these guys cancel. So bring in your last term, which is negative 21. And at this point, I can't move on any further because I'm at x and I'm trying to get to negative 21. And I can't because the degree of x is higher than my remainder. So this is my remainder in my long division, and I pretty much stop there. So my answer is that x squared minus 4x minus 21 over x is the same as x minus 4, the answer I got up there, plus the negative 21 over what I was dividing by. These two expressions are equivalent, and when x gets really, really big, this piece drops down to 0, so my slant asymptote is just that. In other words, whatever your answer or quotient was up top, that'll always be your slant asymptote. So y is equal to x minus 4 is the slant asymptote in this case. And again, all we're doing is we're doing polynomial long division. Let's look at the next one. I have degree on top is 2. Degree in the bottom is 1. So I do my long division. X squared divided by x minus 1. So again, now I'm at x, and I want to get to x squared. So clearly I'm going to need an x to multiply it by. Now x times x is x squared, and x times negative 1 is negative x. And immediately I switch my signs, switch. The first term always disappears. Now the only thing I have left to bring down is x. Now I'm at x, and I'm trying to get to this x. Well, to get there, clearly the only thing I need to multiply it by is a positive 1. So that 1 times x can give me x. Now that positive 1 times the two terms x and minus 1 will give me x minus 1 when I distribute the 1 times x minus 1. And immediately I switch my signs. The first terms always cancel, and 1 is my remainder. And I don't have to go on further because I don't have any x's left. The degree of my remainder is less than the degree of x minus 1, which is what I was dividing by. So my final answer for the slant asymptote is basically whatever your quotient is, y is equal to x plus 1 will be the slant asymptote for this problem. Now sometimes, so slant asymptotes were the only new thing. Long division, you get them, and then the VA and the slant asymptote together with the intercepts can give you a sketch of the graph. Another idea, sometimes we encounter rational functions with holes, and the TI calculator is unable to display this. Whenever we set the denominator equal to 0, you got to be careful. That doesn't always imply a VA like we were used to in the previous videos. So we got to change that up a little bit. Factor the numerator and denominator and see if there are any vertical asymptotes that kind of can be maybe removed, and you'll see what happens graphically when I go through this. So here's example 4 that'll demonstrate this. It says sketch using intercepts and asymptote analysis, and give the domain and the range, kind of like we did for the previous videos. So my function is, so here's what we have, my function, and I'm gonna always factor first. And notice in this case, when I factor this guy, even though you would think, oh, the VA is x equals 0 from the denominator and x equals 2, like we were doing in the other problems, you would not be correct, because notice upstairs I have a factor that can cancel that x minus 2. These guys are the same. So I cannot quickly jump to saying, oh, 0 and 2 are my vertical asymptotes. So I'm not going to do that. I'm going to go reduce this, but I'll keep in mind, so I'm going to cancel this guy with this guy, and that's going to give me a 1 on top, 1 over x. So this is my new function. But I have to keep in mind, you want to remember that x cannot equal 2, because if it does, the original function becomes undefined. So this is my focus now. That's my new rational function I'm going to worry about, and take care of the 2 that I canceled out later. So x equals 2, again, I repeat, is not a vertical asymptote because I was able to cancel out that factor. So I'll go through the steps. Just by dealing with this new function, I'm going to call it g of x, which is a little bit different than my original function, f of x, because I canceled things out. So the VA now from the denominator, quickly, there's just that one VA, x equals 0. The HA, since the degree on top is 1 and the degree in the bottom is, or degree on top is 0, it's a constant, and the degree in the bottom is 1 because it's x to the 1, the VA or the HA has to be 0 because the denominator grows quicker than the numerator and it dies out. For the x-intercept, remember we would set the numerator equal to 0, and if I do that, I get some nonsense that doesn't give me any x-intercepts. And for the y-intercept, when I make x equal 0, it looks like I end up with, again, nonsense. I won't even do it since x cannot equal 0. Remember, that's a vertical asymptote, so no y-intercept. So none for the x-intercept and none for the y-intercept. All we know so far is that we have a VA of, let's go graph. We'll do 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, let's say. We got a vertical asymptote at 0. We got a horizontal asymptote of y equals 0. We have no x-intercepts, we have no y-intercepts. We graphed this function in the very first video of part 1 that we did. We know it's going to look like this and that. But I have to be careful because remember, it was not defined at 2 because I canceled out the factor x minus 2. And now this function that I've graphed in red is not my original function. I have to go account for my original function. So when x is equal to 2, my new function gives me a y value of 1/2. That's when the hole happens. So when x is 2, y is 1/2, and this is where the hole is. X is 2, so y is 1/2. I need to draw my function a little bit more accurately. So here's my function with a hole. The original function that I started with, this guy, looks just like 1 over x, except with this added hole in it. And where that hole happened, all I did was I put that 2 that I could not have into this new function that was factored and cancelled. And your TI will not be able to obviously show this. Let's go to the TI and put this original function in there. So I have my original function x minus 2 divided by x squared minus 2x. And when I do a zoom 6 on it, notice it just looks like the 1 over x function. It doesn't show me a hole anywhere, but I do know that if I do second trace and push 1, and if I say x equals 2, and I push enter, y equals this blank. That's the TI's way of telling me, hey, at x equals 2, this graph has no y value. So there is a little hole in there, it's just that the TI is unable to display it. But by hand, we can clearly show exactly where the hole happens. Now let's look at the domain and range, because we had to answer that too. For the domain, we always exclude the vertical asymptotes. In this case, I have to exclude 0, and I also have to exclude the 2 where the hole happened. So the domain excludes 0 and 2. For the range, I have to exclude, I guess, just the horizontal asymptote, which is 0. So y such that y cannot equal to 0. All right, so we'll do part B. Maybe we'll do part B and the other example in the next video so that we don't rush through it.